Hello everyone. Today we are going to analyze a fixed beam when it carries an eccentric point load. You can see that this point load is not acting on the center. It is acting at a distance of A from the left. Here we have to find the fixed end moments, reactions. Also we have to draw the shear force and bending moment diagrams. Finally we have to find the deflection under the load. Also we have to find the maximum deflection. In this question, first we have to find the fixed end moments. To find out the fixed end moments, we have to make two diagrams. One is free movement diagram or mu diagram and another is fixed movement diagram or mu dash diagram. To draw free movement diagram, we have to consider the fixed beam as a simply supported beam and calculate the bending moment. If in the simply supported beam, point load is acting eccentrically, the formula for the maximum bending moment is WAB upon L. In the same way, we draw the bending moment diagram for the simply supported beam. Here also, we have to draw. This is called the free movement diagram. Now, let us see how to draw the fixed movement diagram. In the fixed supports, there will be movement. In the point A, there is a fixed support. Here the moment is MA. In the point B also, there is a fixed support. Here the moment is MB. Using these moments, we have to make the fixed moment diagram. Here MB is bigger than MA because the point load is near to the support B. MA will be acting in the anticlockwise direction. MB will be acting in the clockwise direction. Using the arrows in the curves, we can make this diagram. Both of these arrows indicates upwards. So the fixed movement diagram comes above the span. Both of the movements are hogging, so the diagram will be negative. Now let us find the area of mu diagram. This is a triangle. We know the formula for the area of a triangle, half into breadth into height. Here the breadth is L, height is WAB upon L. Let's apply the values. Finally we are getting WAB upon 2. Now let us find the area of mu dash diagram. In the mu dash diagram, let us split MB into two parts, MA and MB minus MA, so that this diagram is split into two parts, one triangle and one rectangle. First, let us find the area of the rectangle, MA into L. Then let us find the area of the triangle, half into MB minus MA into L. We can take L outside, then multiply MB minus MA with the half. When we do that, we will get these. MA minus MA by 2, we will get MA by 2. Finally, we are getting L upon 2 into MA plus MB. The area of mu dash diagram and the area of mu diagram will be same. So let us equate both of them. We can eliminate this 2 and this 2. Then let us take L on the right side. It will go to the denominator. Let us keep this equation as number 1. To find out MA and MB, we need one more equation. Here we are having two diagrams, mu diagram and mu dash diagram. In these two diagrams, the centroid distance will be same. Let us find the centroid distance towards the left for both of the diagrams. Then we can equate to make one more equation. First, let us take the mu diagram. For this triangle, the centroid distance towards the left is L plus A upon 3. Now let us take the mu dash diagram. The centroid distance towards the left is L upon 3 into MA plus 2MB upon MA plus MB. This is a trapezoid. Here you can see the standard formula in a trapezoid for the centroid distance on both of the sides. Using this formula, I have made this. Now let us equate the centroid distance of mu dash diagram and centroid distance of mu diagram. Then let us eliminate 3. Then let us take L upon MA plus MB on the right side. It will come inversely. From the equation number 1, we know that MA plus MB is WAB upon L. So instead of MA plus MB, let us apply WAB upon L. L into L, we will get L square. Let us keep this equation as number 2. We have made two equations. Now let us subtract the equation number 1 from 2. On the left side, we have to subtract MA plus MB by MA plus 2MB. Here, MA and minus MA will be eliminated. 2MB minus MB, we will get MB. On the right side, we have to subtract this by this term. Let us multiply this with the L plus A. When we do that, we will get this. We can cut this L and square. A into A, we will get A square. Then we can eliminate these two terms. Finally, we are getting MB, which is equal to WA square B upon L square. In the first equation, let us apply the value of MB. Let us take this term on the right side, so it will become negative. WAB upon L is common. Let us take it outside. For these two terms, let us take LCM. 1 into L, we will get L. We know that L minus A is B. B into B, we will get B square, and L into L, we will get L square. Finally, we have got MA, which is equal to WAB square upon L square. We have found MA and MB. Now let us find the vertical reactions RA and RB. First, I am going to find out RA. For that, I am going to take moment about B. In this case, I am moving towards right hand side. Clockwise will be positive and anticlockwise will be negative. MA is acting in the anticlockwise direction, so it will be negative. RA is acting towards the point B in the clockwise direction, so it will be positive and the distance is L. The point load is acting towards the point B in the anticlockwise direction, so it will be negative and the distance is B. MB is acting in the clockwise direction, so it will be positive. Let us take these three terms on the right side. Then let us take WB outside. Then let us take this L on the right side. It will come in the denominator. Then let us take LCM. When we multiply 1 with L square, we will get L square. L square into L, we will get L cube. We know that L is A plus B. Here, let us apply A plus B the whole square formula. We will get A square plus 2AB plus B square. Let us eliminate minus A square and positive A square. AB plus 2AB, we will get 3AB. From here, let us take B outside and multiply with B so that we will get B square. Finally, we have found the formula for RA, WB square upon L cube into 3A plus B. Now I am going to find out RB. For that, I am going to apply the rule sigma V is equal to 0. RA and RB are acting upwards, so both of them will be positive. W is acting downwards, so it will be negative. Now let us take RA and minus W on the right side. We know the formula for RA. Let us apply that. From here, let us take W outside. Then here, let us take LCM. 1 into L cube, we will get L cube. Then let us multiply minus B square with 3A plus B. When we do that, we will get these. We know that L is A plus B. Here we can apply A plus B the whole cube formula. The formula is A cube plus 3A square B plus 3AB square plus B cube. Then let us eliminate these two terms and B cube minus B cube. From here, let us take A square outside. Finally, we are getting RB, which is equal to WA square upon L cube into A plus 3B. Now, we are going to draw the shear force diagram. For the shear force at just right of A and for the shear force at just left of C, we can calculate the shear force towards the right side. Here, upwards will be positive and downwards will be negative. For the shear force at just left of B and for the shear force at just right of C, let us go towards the left side. Upwards will be negative and downwards will be positive. Using the shear force values, we can make the shear force diagram. Now we are going to draw the bending moment diagram. For that, we have to combine the free movement diagram and the fixed movement diagram. You can see that I have combined both of the diagrams. Now we are going to find out the point of contraflexure. Point of contraflexure is the point where the bending moment changes its sign. Here there are 2 points. For AC there is 1 and for CB there is 1. In AC, let us make a section in the point of contraflexure at the distance of x from the point A. We know that at the distance of x, the moment will be 0. Using this condition, we can find out x. I am going to find out the moment at the distance of x from the point A. In this case, I am moving towards right hand side. Clockwise will be positive and anti-clockwise will be negative. MA is acting in the anti-clockwise direction, so it will be negative. RA is acting in the clockwise direction, so it will be positive and the distance is x. Then let us take this term on the right side, so it will become positive. Then let us take this term on the right side, it will come inversely. Then we can eliminate W, B square and then L square and cube. Finally, we have made a formula for the distance of x, AL upon 3A plus B. For AC, we have found the distance of point of contraflexure. Now let us find the distance of contraflexure for BC. In the point of contraflexure, let us make a section at a distance of x from the point B. In this section, we have to find the moment. I am going to find out the movement from the point B. In this case, I am moving towards left hand side. Clockwise will be negative and anti-clockwise will be positive. MB is acting in the clockwise direction, so it will be negative. RA is acting in the anti-clockwise direction, so it will be positive and the distance is x. We know that in the distance of x, the movement will be 0. So mx will be 0. Let us take this term on the right side. So it will be positive. Then let us take this term on the right side. So it will come inversely. Then let us eliminate WA square, also cube and L square. Finally, we are getting x is equal to BL upon A plus 3B. We have made the formulas for the distance of point of contraflexures on both of the sides. In the fixed supports, there will be no slope. So in the points A and B, the slope theta A and theta B are 0. Also in the fixed supports, the deflection will be 0. So YA and YB are 0. Now we are going to find out the deflection under the load W. In this beam, there are two different parts, AC and CB. So we have to make two sections, one section in AC and one section in CB. You can see that I have made two sections, one section in AC and one section in CB. Both of these sections should be made at the distance of x from the point A. Now let us find the moment in the sections. MA is acting in the anti-clockwise direction, so it will be negative. The vertical reaction is acting towards the section in the clockwise direction, so it will be positive and the distance is x. For this load, we have to consider the second section. This load is acting in the anti-clockwise direction, so it will be negative. For the distance, we have to take this distance. This distance is x minus a. We have calculated the moment from two sections, so we have to divide it by the line. Now let us equate mxx with EA d square y upon dx square. Now let us integrate on both of the sides. When we integrate EI d square y upon dx square, we will get EI dy upon dx. For integrating these two terms, we can apply this formula. For integrating this term, we can use this formula. After the integration, we will get this. C1 is the constant. We know that dy upon dx is the slope. So this is the slope equation. Let us keep this equation as number 3. Now let us integrate this equation again. When we integrate, we will get this. C2 is the new constant. After simplifying this equation, we will get this. In the point A, there is a fixed support. In the fixed support, there will be no slope. We know that dy upon dx is the slope. So when x is 0, dy upon dx is 0. In this equation, let us apply x is 0 and dy upon dx is 0. When we do that, we are getting C1, which is equal to 0. When we apply the values, we have to be very careful. We should not consider this term because this term is only applicable beyond the point C, but now we are applying the limits in the point A, so we should not consider that term. In the fixed support, there will be no deflection, so when x is 0, y will be 0. In this equation, let us apply the value of C1 and x is 0 and y is 0. When we do that, we are getting C2, which is also 0. When we apply the values, we have to be very careful. We should not consider this term. We know that this term is only applicable beyond the point C. In the EIY equation, let us apply the values of C1 and C2. When we do that, we will get this equation. Let us keep this equation as number 4. Now let us find the deflection under the point load W. Here the value of x is A. So instead of x, we have to apply A. Then let us make a common denominator. I wanted to make this denominator 6L cube. For that I have to multiply the numerator and denominator with 3L. When I do that, I have the common denominator. Now we can take WA cube B square upon 6L cube outside. Then we will have this. For L, we can apply A plus B. Then let us multiply minus 3 with this value. When we do that, we will get this. Then we will eliminate minus 3a and positive 3a. Minus 3b plus b, we will get minus 2b. B square into b, we will get b cube. Then we can take this EI on the right side, so it will go in the denominator. We got a negative value, that means it is the downward deflection. Finally, we have found the downward deflection at C. YC is equal to WA cube B cube upon 3L cube EI. Now we are going to find the maximum deflection. Let us keep A is bigger than B. In this beam, we have already made A bigger than B, so no problem. If A is bigger than B, the maximum deflection will occur between A and C. When deflection is maximum, the slope will be 0. Previously, we have made one equation for the slope, that is the equation number 3. In this equation, we should not consider this term because this term is only applicable beyond the point C, but the maximum deflection will occur between A and C, so we should not consider this term. We know that C1 is 0. According to the condition, we have to make the slope 0 so that we can find the value of x. Let us take this term on the right side, so it will become positive. Then we can eliminate x and square. Then let us take this on the right side, so it will come inversely. Then let us eliminate WB square and WB square. Also let us eliminate this cube and L square. Finally, for x, we are getting 2AL upon 3A plus B. We have made one equation for the deflection, that is the fourth equation. In this equation, instead of x, we have to apply this value. Here and here, I want a common denominator. So in this term, I am going to multiply the numerator and the denominator with 3L so that I will get the common value. Now from these two, we can take this outside. Then we can eliminate 3a plus b. Then we can add these two terms. When we do that, we will get minus al. Then let us take this negative outside. For this value, we can make square so that we will get 4a square L square. A square into A, we will get A cube. L square into L, we will get L cube. So that L cube and this L cube will be eliminated. 2 2s are 4, 3 2s are 6. Then let us take this EI on the right side, so it will come in the denominator. Finally, we have made one formula for the maximum deflection. We are getting a negative value, that means it is the downward maximum deflection. Now we are going to end this session. Thank you for watching this video.